Welcome. We'd like to walk through developing the compound interest formula. It's a formula that gets used fairly often. We'd like to be able to use it in this course as well. So suppose that Mike invests $1,000 at 8% interest for 1 year. We want to find the future value of his investment if the interest rate is a simple interest rate. That is, it is simply computed once at the end of the time. And the value that we're going to get here is $1,000 times, we looked at this previously, it should be 1 plus RT. The interest rate is 0.08, so 8% times the time of 1 year. So that is going to be $1,080. So the future value is, again, that $1,080. Now what we want to do is we want to take a look at what it would be like if we computed interest partway through the year. So if we calculate interest every 3 months and whatever interest is accrued over that period is added to the principal as we move through the next period. So we start off with an initial value of $1,000. So at time 0, we have $1,000. And now let's see here, at the end of 3 months, what we have is we have that $1,000 times 1 plus. Now, this is still a simple interest scenario, simple interest calculated now at the end of the 3 months. So we get the interest rate of 0.08, but the time that we've traveled through in years is only 3/12 or 1/4 of the year. So this is 1,000 times 1 plus 0.08 divided by 4, if we wanted to write it that way, which is enlightening. So we'll see that in just a moment. But this gives us $1,020 at the end of 3 months. Now, at the end of 6 months, 3 additional months have passed, but now our value that we're calculating the interest on is $1,020 instead of $1,000. And again, it's passing through 3 months. So 1 plus 0.08 divided by 4, right? It's that same number here, 8% times 1/4 of a year. Now we get a value that is, let's see here, $1,040, but not just $40. We also get an additional 40 cents. Hey, excellent, a little bit extra. What I'd like to point out, though, is that this can be observed as 1,000, right? The $1,020 can be computed as the $1,000 times 1 plus 0.08 divided by 4, right? That's what the 1,020 was. And we're still multiplying by this. So we still have 1 plus 0.08 divided by 4. So we can recognize that this is actually 1,000 times 1 plus 0.08 divided by 4 raised to the 2nd power. So that's pretty interesting. All right, so at the end of 9 months, we're now taking this value, the $1,040.40, and we're moving it through 3 months, right, from 6 months to the end of 9 months. So we've got 1 plus 0.08 divided by 4. And this value is going to give us 1,061.208. So we'll call it 0.21. That looks pretty good. So yeah, we've made an extra $1.21 over what we would anticipate based on just simple interest, right? It'd be $20 each time if we were just computing it on the $1,000. 20, 40, 60. But we can recognize again that this 1,040, this thing was given by 1,000 times 1 plus 0.08 divided by 4 raised to the second power. And this piece is still the 1 plus 0.08 divided by 4. So overall, we can write this as $1,000 times 1 plus 0.08 divided by 4 raised to the third power. Now, are there simplifications that can be done here? Of course there are. I can take 0.08 and divide it by 4 and find 0.02. That's fine, but I don't want to do that because I want to look for a pattern here, which is quickly arising, and that pattern in reference to the numbers that we have given in the problem. So to complete the passage of time, so the end of 12 months, the end of the year here that that the money is traveling through, we take that previous balance of $1,061.21. We multiply it by the 1 plus 0.08 over 4, right? We're moving it forward through 3 months. Simple interest computation here. And that's going to be $1,082.43. It's actually, that's approximate. So 43 cents. There we go. So that's some rounding occurring. But we know that this thing, again, the $1,061.21 can be written as 1,000 times 1 plus 0.08 divided by 4 raised to the third power. And I've still got this piece on there, 1 plus 0.08 divided by 4. So I can write this as $1,000 times 1 plus 0.08 divided by 4 raised to the fourth power. And what I can observe is that this is that initial amount given, or that initial amount invested, $1,000. The 4 is the number of compounds per year. If it's compounded every 3 months, then it will have 4 compounds in a year. Number of compounds per year. We have the interest rate, yearly interest rate. And we have the number of compoundings. And that number of compoundings can be computed as 4 times 1, the number of compounds per year, times the number of years that we're moving it forward. In this case, just 1. So by making that observation, we can find that future value is given by the initial amount invested times 1 plus this interest rate, we could call R, divided by the number of compounds per year, we could say N. And then how many compounds does it go through? Well, it goes through however many compounds per year multiplied by the number of years. And this gives us a formula for the future value of an investment invested at R% yearly interest, compounded N times per year, invested for T years. And that's precisely what we have on this page here. So compounding period is that 3 months. We can look at it as the number of compounds per year N. That's the thing we're really interested in. The interest rate is R. The term or the number of years invested or borrowed is T. And then the principal amount, that initial amount invested or borrowed, is P. And that gives us a definition for compound interest, or a definition for a compound interest formula. So this matches what we just discussed on the previous page.